I want to welcome everyone to the Python for Beginners webinar. This is an energy and data webinar series. Today our presenter is Alec Walker. He's co-founder and chief executive officer of natural language processing and data analytics firm Delphin SIA, based in Houston. Delphin helps the oil and gas industry extract value from unstructured data. Alec also founded and runs INLI, teaching oil practitioners computer and data science. He has led digital transformation and internal entrepreneurship projects for a variety of leading organizations, including Intel, Inditex, AECOM, and General Motors. He has worked for Shell as a technical service engineer in refining, a tech tools software product manager, and a reservoir engineer in non-conventional oil and gas. He holds a bachelor's degree in chemical engineering from Rice University and an MBA degree from Stanford Graduate School of Business. This presentation today is copyrighted. The rights belong to the author. So for those of you not familiarized with energy and data, this is a conference that is organized by ATG, SPE, and SPE. It is an immersive, interactive, and integrated event that gathers professionals to define the digitalization of the oil and gas industry influenced by experiences and implementations from outside the industry. The next event will be held in Austin, Texas. We hope that you will join us there. We have scheduled a series of webinars that are part of this webinar series, trying to build the community knowledge and integrate the community and get all of you to work together through digitalization, even if you're new to it. So we invite you to follow our series and to follow our postings in LinkedIn, Instagram, to be in the lookout for the event. And with that, the next thing I want to do is just run a quick poll so we can understand what domain everybody has. So the majority of the population we have today are geophysicists, 55% of them. 29% are geologists, 1% computer scientists, 9% petroleum engineer, and then we have other domains. The representation is about 5%.
All right, thank you so much. So there's a lot to cover today in just an hour. I want to set expectations. I don't think that we're going to get deep into kind of scripting language and other similar questions about the context of Python. And I also want to make sure that setup. Actually, I'm going to cover setup first. And that's because there's a rather large download that I'm going to encourage you to get started. And so while that download is happening, I can still be talking about context before we start actually playing with Python together. So for that setup, the best thing to do is to follow this link here, anaconda.com/download. So Anaconda is probably the most popular way for people to interact with Python. And it's a great tool, and I'll show you what it looks like when I click this link here myself. Pull this page in. So when you click on that, you'll go into something like this, and there's this download button. And if you click on that download button, it takes you down to the place where you can download Anaconda. And I'm sure you've downloaded and installed software before. So when you click on any one of these links, it will download it to your computer. You can then open it and follow the instructions to install. If you're a Mac user, I recommend getting the graphical installer rather than the command line one. It's only 12 megabytes more, and that way you can just kind of follow through like a wizard and hit next and go with all the defaults. If you're a Linux user, Power8 is pretty popular, and notice that it's kind of a lighter load in terms of the download size. And if you're a Windows user, you have this choice between 64-bit and 32-bit. You should go with whatever your computer is, and a quick way to check that is to go into your control panel. So what I do is I just click on my little magnifying glass there, and then if I type the word control, the control panel comes up. And you'll see what I'm now showing you on the screen. So you want to click on System and Security, and then on System. And then there's a 64-bit is at least what it shows up for mine. Yours might say 32-bit. So that's how you then can know whether you want to click on this 64-bit or this 32-bit to initiate the download. I don't think it shows, I just exited that window because I was going quickly. I don't think that Python 2 is available anymore for download from Anaconda. Pretty much everybody has moved on to Python 3. Slight differences there. If you're just starting Python, now's a good time to do it because people are moving away from legacy code in Python 2 and everybody is embracing Python 3. So it's a good time to kind of get started because you're at the beginning of a long, hopefully, era of Python 3. Once you've downloaded and opened Anaconda, the first thing that'll pop up is this window here. And this is basically asking whether you want the error reports and usage information from your Anaconda interaction to be shared with the Anaconda team. And if you click on this Don't Show Again box, it's kind of hard to get it back. So if you're using Anaconda and Python for work and your company is strict about who gets to access and see what you're using, you probably don't want to check this box. But otherwise, I encourage you to check the box. If you're just playing around with Python to understand how it works and trying things out, this is a great community and they provide a free tool. So I think it's kind of nice in return to check this box and say okay there. So I'm actually going to open Anaconda to show you what it looks like. So when you open Anaconda, it'll pop up and look something like this. It could be that each of the icons for these various programs here are smaller, but it's the same basic thing. And the one you want to click on is this Jupyter Notebook. So that's different from the Jupyter Lab. There's two things with Jupyter with a PY for Python. There's lots of little cute names that include PY in them because they're references to Python. So Jupyter, Jupyter. So you'll see a lot of that. So if you're wondering why are there so many PYs in all of these alternative spellings of words, that's the reason. So if I click on Launch here, what will happen is it'll pull up Python in a web browser. So something like this will pop up. And for me, my default web browser is Microsoft Edge. And that's because I use this for work sometimes, and some of the clients want Microsoft Edge. So, okay. And this looks a little bit like a Windows browser. So if I were to just open a Windows browser here, you'll see the same folders. So I've got my 3D objects, Anaconda, contacts, 3D objects, Anaconda, contacts. So I'm seeing the same things here, and I can browse through my folders this way. And if I want to create a new file, all I have to do is click on New, and then I have an option to create a new terminal, a folder, a text file. But what I want is Python 3. So that might have seemed fast. I'm going fast on purpose. I know this is being recorded and I only have an hour. So don't worry if you're not completely to where I am yet. If you've already downloaded Anaconda ahead of time, you might be able to open up a file like this right now. Otherwise, I encourage you to continue to click around with it as I'm talking about the context for Python. So you can change the name here. So I might just call this example. And now if I look back at my page here, I have an open PY. So this is an Python notebook, and it's green showing that it's open. So this is where you want to get to. Okay, coming back to the presentation here, the next thing to talk about is the context for Python. So my other company, when Annabella was introducing me, she mentioned this company, Delphin. We do work for oil and gas clients. And we asked our clients, what tool dominates your workflows whenever you need to manipulate and analyze data to make decisions? And the survey results we got back showed that Excel was like the overwhelming winner. 92% of people say that it is their default tool for any sort of workflow that involves manipulating data or analyzing data. And data analysis is, data science. So manipulating data might be something like you're, gathering a bunch of financial information to make a business decision. or you're organizing a bunch of well logs to take a look at what happened in a well or something like that. MATLAB was the second most popular, but big lag, at least in the people we were talking to. And then R, which has been kind of traditionally academic. And then Python, only 7%. SQL and then other. And there's a long tail here of people using, very small amounts of people using a wide variety of different tools. So who did we ask? We asked oil majors, independent operators, service companies, private equity shops, professional societies, all in the energy industry in order to come up with this information here. And we also got some information about what kind of people were filling out this survey. And they look a little bit like the demographics that we showed from the poll we just took at the start of the class today. So a lot of geoscientists. These are non-technical, think of middle management here. Reservoir engineers, drilling, completions consultants. Consultants might have various backgrounds overlapping with some of this other stuff. So, and then IT, it's important to note, these are not data science IT. These are people like, information systems manager or applications team lead, something like that. These are people who are using Excel for the most part without using Visual Basic for applications in Excel. In other words, they're using Excel, but they're not writing any scripts to help automate or expedite workflows. And I don't have data to show that in survey results. That's only just from anecdotal evidence from talking to people. So that's kind of like a snapshot, perhaps, representing the oil and gas industry. And it's probably an American, United States of America centered snapshot. So not perfect, but I want to draw a distinction between that and the rest of the world. So if you ask the rest of the world this question, what tool dominates your workflows? I'm not sure if this was the exact question that everyone who did this research asked, but it was something like that. And the results you get from 2015 and 2016, thanks to D-Zone here, who published the results in 2017, show this spread of tools by popularity. There's R kind of at the top there. But notice Python's growth rate is like 50% year over year from 2015 to 2016. And there's Excel down there, fast growth rate. Interestingly, given that Excel is the incumbent tool, it's had enjoyed very wide market penetration for a long period of time, but still is growing. SQL, a few other things. I don't see MATLAB on there at all. And then KD Nuggets did a similar survey, hundreds of thousands of people or so in 2019, showing 2017, 2018, 2019, so the next 3 years of the 5 years leading up to 2020. And Python has emerged as kind of the most popular here. And we're not seeing, continued growth there, maybe because we've kind of saturated already. But Python is far and away kind of the most popular. And Excel is still up there too, perhaps because in Excel you don't have to actually script anything, and it's so visually appealing to just see your data in 2 dimensions. So what about 2020? What's going on in 2020? So if I just do a search for Python popularity in 2020, and I scroll down, why is Python so popular? Top 10 in demand, meteoric rise in popularity. You kind of get a sense, okay, Python is really taking off here. People love Python and it's being used for all kinds of things everywhere. Why is that? If I go back to this second link here, this is an article I found that I thought did a pretty good job of answering that question. So thanks, Nick. Top 4 reasons Python is so popular in 2020. I'm just going to scroll right down to the answers here. Why is Python so popular? It's one of the best languages when learning to code. That didn't used to be true in my experience. I thought Python was actually pretty tough to learn when I first started. But Jupyter Notebooks and maybe Google's Colab make it so easy to debug and figure out what you're doing, and I'll show you guys that in a bit. So it's become much easier to use and to learn and to explore than it used to be. It's heavily used in the Internet of Things. Okay, there's lots of sensors in oil and gas. There's lots of sensors everywhere, so Python works really well with that. In other words, when it's having to interact with actual machines in the real world, it does a very good job and it's pretty quick. Python is instrumental in data science and AI. I'm going to talk a little bit more about this in a bit. Data science and this buzzword artificial intelligence here, definitely enjoying a very popular resurgence from something like a winter over the last, I don't know, 20 years or so before it got popular again. And Python is just so good at this. Things like it automatically helps to utilize parallel processing. It can execute extremely quickly, almost like Fortran in kind of a machine code level, but you can write it in a very high level, as though it's utilizing a bunch of built-in processes under the surface. And it's versatile for web development. That's probably less relevant for oil and gas industry, given that it's a commodity, but that helps to explain its popularity overall. Okay. So I talked about data science enjoying a popular resurgence. This is worth kind of focusing in on just a bit, because Python is just so darn good at this. It helps to show the context. So a lot of what people are using Python for in the energy industry is like, wow, hey, we can apply some data science methods that help to drive our decisions. So it's not just about automating or expediting our workflows. It's not just about getting more work done quicker. It's also about the concept of machine learning and data science. Hey, we have to make tough decisions here. Are they fully informed? What does our data suggest based on what we've seen in the past? And how can we discover dependencies that perhaps aren't as obvious to humans, even experienced humans in the energy industry? So data science is enjoying this really popular resurgence here. There's two main reasons for that. One is an increase in computing power, and the second is an increase in the availability of data generally. So increase in computing power, don't worry about trying to read this whole thing. The font is small. What's important is just to see the trend here. So this is Moore's law. This is a concept in computer science and computer engineering that's, I can't remember when Moore came up with this, probably 1971, I guess, given that that's when the graph starts. But, that's not necessarily true. It could have been more recent. But the concept, this person with the last name Moore figured out that every 2 years or so, we can expect the amount of transistors on a circuit to double. So essentially that means that the computer gets twice as fast and can handle twice as much workload given the same size transistor every 2 years. So that's what we're seeing here. And the ramifications of that are, now in 2020, most computers contain more than one processor, each capable of doing quite a lot of calculations per second, which means that methods in machine learning that used to be much more expensive and expensive in terms of computation are now accessible even on computers that aren't supercomputers in, say, academic circles or universities. So they're much faster to do, and we have they're more available to us. Moore's law also describes the cost to produce chips and how that's dropped, which translates to consumer prices. So my laptop is like a $700, pretty cheap laptop, but I run Python and do machine learning on some pretty large data sets right here on my hard drive without having to leverage cloud computing so much. And that's become more and more possible. So essentially, this slide is the takeaway here is data science methods work better and are more available to more users. That's what the increase in computational power has allowed. So it's kind of a level playing field now. Everyone can mess with data science, at least to some extent. If you want to be like the best in the world and come up with the absolute best trained model on the largest data sets, that's kind of reserved, unfortunately, for the companies that are the most powerful in the software world, because they have access to the most data and they have access still to computers and computational power that's far exceeds my $700 laptop. But that doesn't mean that I can't play too and get some good stuff done, especially in a niche like oil and gas. So the second reason here is an increase in availability of data. So many around the world are collecting data sets. 2018 IDC, this is kind of seen as sort of a expert group in predicting and disclosing what's going on with data around the world. predicted that worldwide data would grow from 5.3x, grow by that amount by 2025, so in 7 years. So okay, there's a lot more data, but more of the data sets are much more available publicly. So they also predicted, IDC, that 49% of the data would be stored in publicly available cloud environments, with 30% of the data analyzed in real time. That's impressive. Is your data analyzed in real time? So before we can start digging into Python, I'm going to show you how Python used to work. Because remember, one of the big selling points of Python is that it's easy to learn and it's easy to debug. That didn't always used to be the case. If I open a text file here, this is just a notepad. Let me just open, I think I had an example. Oh yeah, here we go, nice. Oops, too big. So here's some Python script. And it used to be, if I wanted to run this script, I would have to open up my command prompt in order to do it. So I'd open up my command prompt and I'd say, hey, I want to run Python on this file right here. And then maybe it would throw an error and say something like, oops, you tried to divide by 0. Python doesn't know what to do about that. Fix your problem. And then I'd have to go back in here and just kind of scour this and think, it made sense to me when I wrote it. Why am I having this problem? And it could take a really long time to kind of find my bug and fix it. So the next generation were things like, if I open, say, Sublime Text Editor, and nice, it pulled up a file for me that I was messing with just recently to kind of show you guys some things in Python. So this is essentially Notepad. This is the same kind of thing, but notice it's color coded here. So I have my commands in kind of pink red, and my variables are in white. I have my functions in blue, my strings in yellow. So it kind of helps me there. And notice also that if I mouse over something like this variable player wins, and I click on it, and it takes me down, it shows me where I've actually used that in my code, which is really handy. So it kind of got better and better. What I'm seeing on my screen matches this thing on the side. So this program is called Sublime Text Editor. I like this one a lot, and it's free. So feel free to search for it online and use it if you want. I use Jupyter Notebooks way more than I use Sublime Text Editor these days. But if I were to, so this is my command prompt. If I pull up what folder my command prompt is looking at, command prompt is just, it's part of your computer, and it's called a terminal on your Mac computer if you're using an Apple computer. So I type in dir, and it'll show me what directory I'm looking at. And you'll notice that it's the same directory that, my basic, here's my Alec Walker, like home directory, where I've got 3D objects, Anaconda, contacts. Those are the same things that we're seeing here, 3D objects, Anaconda, contacts, whatever. So I can change my directory to be a directory where something else is going on. For example, I'm copying, I'll show you how I do this. I go to the directory that I want, where I have some Python files, and then I can click up here and it'll give me that directory name. And I can copy that and paste that into my command prompt and say cd, that means change directory. And then when I hit enter, I'm now in Documents 2020 setting up Python and then my Blackjack folder. So if I now do dir again, it shows me what I'm looking at here. This is kind of clunky, but it's the same thing as essentially like, clicking around inside of folders until I'm in the right folder I want. So now my command prompt is looking at this folder, and I can then execute some Python. So I could write something like Python blackjack.py. So I have this blackjack.py program that I wrote, and it's now executing in the command prompt. So it says, here's a simple blackjack game made with Python. Blackjack is a card game, so this is sort of a simulation of a card game. What's the value of the chips I'm buying? Okay, let's say I'm buying 100 chips, and I'm betting 50 of them in my first hand. ooh, I have a nice opening hand of a jack and a 10, so I'm already at 20. I'm going to stand, and we'll see what happens here. Oh, the dealer won because they got to 21. Shoot, so now the value of my chips is down to 50. So that's the kind of thing that people used to do in Python. This is a silly example, making a blackjack game. Probably there's more productive things we could think of, but this used to be how we would interact with Python. And this code that's running here is that same code that I had open in my Sublime text editor here, right? Okay, so that's enough on context. That's how Python used to be. Let's actually dig into some basics, and then I will showcase for you some things that that perhaps are more exciting than the basics that you can build towards when you get the basics down. So let's get back into the Jupyter Notebooks here. 4 things that I love about these Jupyter Notebooks. They're great for documenting what you're doing, and I'll show that to you. You don't have to just comment your code. You can actually write, it's almost like Microsoft Word. You can write whole paragraphs and, import pictures and things like that. You can point at different areas of your code and say, hey, this part is doing this and this next part is doing that. You can check progress as you go and debug. So line by line, you can execute and then pause Python and take a look at what's happening behind the scenes. And that really helps you to learn it, but it also really helps to debug and to share your work with others. It can be easily published online and then referenced, which is great. So you can just share notebooks with people you're collaborating with, whether they're in your team at work or in an open source community. And it comes with all kinds of popular packages and libraries that do all kinds of interesting things. And I'll show you how you can download and install more packages pretty easily inside of Python. Right, so before I show you that, let's actually dive into Jupyter Notebooks and show some examples here. All right, so here is my Jupyter Notebook that it's just a blinking cursor here. And notice I have this little IN with an open and closed brackets and nothing inside it. This is Python's way of telling me, hey, I'm expecting code in this cell. So each one of these rectangles here with a cursor in it is a cell. I'm expecting code in here, but I don't have any code yet. So if I write something like a equals 3, and you can follow along with me if you have one of these open right now. So I'm creating a variable, and I'm setting it equal to 3. And then if I hold down on Shift and hit Enter, what that does is it executes this line, and now there's a 1 here. That tells me that Python has seen and run this code and that there have been no errors. So now if I ask for A and do another Shift Enter, then I get an output, which is 3. Hey, good. So A is stored as 3. And notice this is a number 2 now. So this is the second line that Python has seen. If I come back up here to this one and I do Shift Enter, Python says, okay, I'll run this again. So now A is set equal to 3 again. It was already equal to 3, no problem. Now it's equal to 3 again. And if I come down here, say, and ask for A is still equal to 3. So what you can notice here is that the order that I've created things in my Jupyter Notebook doesn't necessarily correspond to the order in which I've executed things in Python. The other thing you can notice here is that even though I'm executing one block of code and then later I'm executing another block of code, Python remembers whatever variables I set up or functions I created in previously run blocks of code. So that's pretty handy. It's like I've got lots of little scripting environments and they're each communicating with each other. So I'm not sure why this didn't happen earlier. It makes so much sense in retrospect, but this kind of thing is super useful. Where you can get in trouble here is, so I did Shift Enter there and I skipped this line. Let's say I write B equals 4, but I don't enter it, and I come down here and I ask for B. Well, I'm going to get an error because B is not defined. Python doesn't know what B is because I haven't actually run this line yet. So you have to make sure that you run a line before you then try to reference any code from inside of that line. So just some basics there on how this thing works. This is called the kernel, K-E-R-N-E-L. And if I ever want to, I can, even if I'm busy executing and I've created some sort of infinite loop that would ordinarily crash my code, I can pause that infinite loop in this kernel drop-down menu here without having to delete my work or even exit out of this or Control-Alt-Delete or anything like that. So pretty handy to just be like, wait a minute, I want to click on this kernel and say restart and clear output or any of these other options in the kernel. And when I do that, notice the kernel is completely reinitialized. Python has forgotten everything that I've entered in here, but my Jupyter Notebook still remembers all of the script that I wrote. So now I can go in here and do Shift-Enter on all of these things, and everything works for me. So whenever I want to, I can kind of restart the kernel, or I can interrupt the kernel, or I can restart and run all. And if I restart and run all, it does kind of like restart and clear, but this time it actually goes in order and runs everything that it can. Something interesting about Python that might be different from what you're used to if you have experience in other scripting environments, maybe particularly if you have experience in Visual Basic for applications used in Excel, is that Python's index runs from 0 up until the latest thing, like whatever your higher boundary is. So to show you what I'm talking about there, let's say that I want to, I'm going to create a list. I'll call it my list, 2, 3, 4. So this is a data type. There's a lot of different data types in Python. And this one is a list, and it contains 4 entries in it, 4 items in this list, 1, 2, 3, and 4. And if I say for I in range, and notice that for the command turned green, and then in turned green, these commands that are like used in your scripting in Python, they turn a certain color, kind of like how we saw in the Sublime text editor that we opened earlier. They turn a certain color, and that helps me know that I didn't, mistype them if I accidentally typed FRO. Python doesn't turn this a different color, which means it's going to try to treat this like a variable, and then I'll get an error if I try to run this, because it doesn't know how to do a space and then another variable. But if I do for I in range, and I wanted to go through each of these things, if I set 0, comma, and then 4, what Python is going to do is start with 0 and count up to until, but not including 4. So it'll do 0, and then 1, and then 2, and then 3, and then it'll stop. So if you're not familiar with the for loop, don't worry about this too much. I'm just telling Python that I want to do something a certain number of times. And each time I do it, I'm going to change this variable I. So that way, inside of this code, I can do a different thing. Even though I've only coded Python to do one thing, I can actually do 4 different things. So maybe I want to take, my list and then say I, and I want it to be equal to my list I plus 2. I don't know. So if I run that and then I ask, okay, what's my list now? I see that I get back my list, but I've added 2 to every element in my list. So I'm just showing you about this index here. If I ask, hey, what is my list 0, then I get back just the first element of my list. So indexing starts at 0, and then it ends 1 short of the length of the list. So what's the length of my list? Well, it's 4. In fact, I could ask, what's the length of my list here? And I get back that there's 4 elements in my list. There's 4 items in there, right? But when I'm actually indexing, then I start with 0 and go to 3. That could be a little bit tricky, but it actually, tricky at first, but it's actually super handy, and it saves you a lot of headache when you're doing things like iterating through multiple lists and dealing with math related to what index you're on, because you don't want to accidentally add something necessarily to the first item if the first item's index is still just the first item. Typically you'd want to wait until you're on the second or third to start adding something to it. So the first one, if the index is 0, hey, that's handy. Then whatever you would add ordinarily just doesn't get added because you've got a 0 thing to consider. So there's a lot of ways that this comes in really handy. Don't worry too much if this is like confusing for now. I just want to show you that Python works different from other applications if you haven't seen that before. Some other basic things in Python. There's something called a tuple. So let me create a new, I'll just call it my tuple. Tuples are like lists, but they're what's called immutable. So if I do 1, 2, 3, 4, and I create this tuple and I ask for my tuple back, I get 1, 2, 3, 4. If I ask for my list back, I get 3, 4, 5, 6. But notice that they're wrapped in different kinds of brackets. These are in parentheses and these are in square brackets. The list I can mess with. I can delete things. I can move things around. I can shuffle it. I can do all kinds of interesting things with my list here. Whereas the tuple is meant to be like, hey, this is protected data. Like you can reference this and look at it and run calculations on other things based on this tuple, but it's meant to be protected, which is a nice feature to have. So that way you don't accidentally destroy your data inside of your Python scripting here. Other things to show, if I do inside of, so far I've only done basically one line in every single code that I've written here. If I say A equals 6 and B equals 7, and then I ask for A, notice earlier I said A equal to 3. Python has no problem rewriting A to be 6. If I ask for A down here, it gives me back A. If I then put B down here, notice it only gives me back B. So if you ever ask Python for something inside of a single cell, it'll only give you back the latest thing, the most recent thing that you asked for. And the way to get around that, if I want to see all the stuff in here or multiple things in here, is I use this print command. This is very common. So this function print will print whatever I put inside it. So I can put A comma B and then print that, and it'll give me 6 and 7. Or I could do A and then do another print command and say B. It'll give me 6 and then 7. This print command comes up quite a bit. Okay. There's so many things to show you. I don't want to just keep diving in, and I'm going faster than I ordinarily do when I'm teaching, just because I'm conscious of the time. So maybe what I'll do is I'll move on to showing you a little bit more advanced things that you can do in Python. Here's a whole bunch of example code. I'm importing things. So Python is pretty lightweight in Jupyter Notebooks, which means it can execute quickly and doesn't take up a lot of processing room, temporary storage room on your computer when it's open. And the reason that that's true is that it doesn't bring with it everything that it knows. So if you want to do more in Python than the basic things that I showed you before, for example, you want to be able to import Excel files and manipulate data and graph things, then you have to actually import whatever library you're talking about, whatever library you're interested in, into the Jupyter Notebook. So in this case, I've imported a whole bunch of stuff. And notice it's thinking for a little while before it's actually ready to run. That's because a lot of these things are pretty heavy lifting libraries that do a lot of interesting things. So what I'm doing here is I have a whole bunch of, I'm just going to execute for a little bit. I have a whole bunch of data that is, this is my oil well data. It's actually like the cost of well pads. And I've messed with the numbers here so that, I'm not giving anything away that I'm not supposed to. But we can see like some various information about the well pads, including the cost for that well pad. And I want to maybe do some machine learning to like get a sense for whether I could predict the, we could predict the well pad cost. There we go. And so what I did just right here is I removed this ID from the beginning, because when you import, typically, if you have some data in like an Excel file, you have one column which is just the ID for that sample, but Python automatically assigns another ID column. You see that over here on the left, and it starts with the 0th index, whereas Excel typically you start with the first index. So I just removed that, and this is just one of very many commands and cool things you can do to manipulate data. But anyway, so I'm just going to cruise along here and show you some graphs. So before I fit my curve, I'm just going to do linear regression here. This is the pad area and the pad cost. And, you know, so the cost as a function of pad area. I want to fit this line to this data. I just want to show you how visualization works. You know, I can do a 2D graph. Maybe later, after I do some fitting here, I can do a 3D graph where I have 2 input variables, 2 of my features for my well pads, and I'm trying to display my data by actual cost as a function of 2 input variables. I could show a 3D graph. So here's a line that's starting to fit some data, but it doesn't fit very well. And if I do a little bit more iterations here, then I can see that my, here it is, it's starting to fit a little bit better. So this graph resembles this graph, zooming in on the same points here, but we see that the line that is supposed to be a best fit line is fitting a little bit better. In Excel, you can just like ask for a best fit line when you plot something, right? I'm just recreating that tool here in Python. I don't have enough time to tell you exactly how, but that's what I'm doing. And just to show you that there's some interesting other things you can do, let's look at a 3D plot here. So here's a 3D plot where I have this, what says y-axis is actually my second input variable. So I have the area of the pad, which you would expect correlates with the cost of the pad. But then I have some other, you know, information about the pad, and I can't remember what that was. And I'm only showing 5 data points here, just so it's not too crowded inside of this. And Python's cool in that this dot is a little bit less opaque than, say, this dot, which means this dot is further away from the viewer. So this dot is kind of, in 3D space, it's kind of hard to see that. So this dot is a little bit closer to the origin there than this dot, or say this dot. But if I want to, I can actually like create a 3D graph that looks like this, that I can then like zoom around and like see how we're doing here. You know, how does this line seem to fit this data? And in this case, I forced the line to be 1-to-1 for each of my 2 inputs. So it has to, you know, directly bisect this this plane here, but the slope is what I care about. Is this slope kind of representing these dots? And it seems to be. So, you know, things like that. You can do a lot of really cool things in Python. There's also a lot of fancy built-in methods. So support vector machine is one very popular data science method, and there's some really cool things you can do with support vector machines in Python using the scikit-learn library. So here's my scikit-learn. I want to, well, actually before I do that, let me show you. So scikit-learn, that's in metrics. All right, so here we go. From scikit-learn, I import something called support vector classifier. So that's a type of support vector machine. If you're not sure what a support vector machine is, you know, it's really fun to learn about this kind of stuff, and I'd love to talk about it more when I have more time. And so you set the model equal to, you know, some variable that you can call what you want, equal to this support vector classifier, and then you can just fit it to data. And this data is multidimensional, like input data. And then this is our dependent variable, what we're trying to fit to. So that's how machine learning works. And we wind up with, in this case, what I apply this to is a built-in data set that just comes with scikit-learn that's useful for playing around with. And it's 569 instances of breast cancer. And the goal is to predict whether an instance of breast cancer is malignant, the cancer is malignant, or the cancer is benign. So there's only 2 possible outcomes, which is why we have a matrix of, or this is just a list of 0s and 1s here. So if we want to predict this, we can use methods like a support vector machine or random forest or, you know, linear regression or whatever it is that we want to use, some other kind of regression. And we can run a support vector classifier on it, and then we get an outcome that we can then measure against the actual results from our training data. So in this case, we actually knew whether each one of those examples was malignant or benign. And when we get this thing called a confusion matrix, this tells us, hey, for 56 cases here, these are the true positives. We said these are malignant, and we were correct about them. And for these ones, these are the false positives. We said, hey, these are malignant, but we were wrong. And here are the false negatives. This is bad in the case of cancer. We said, hey, for these cases here, these are not cancerous, but in fact they were. And then we were correct on these ones, the true negatives. For these cases, hey, we said that there wasn't cancer, and we were correct, there was not cancer. So we can learn more about how our model did by asking for classification reports. If you've been doing machine learning, say in Visual Basic or in MATLAB, the tools are, in my experience, a little bit less powerful. I hesitate to just draw objective comparisons because it is kind of subjective. Some people really prefer some tools, some people prefer others. I've already talked about why Python is so popular. But executing this kind of stuff takes less than a second, even on a, this isn't a huge data set, but even if I have a really big data set, it can still go very quickly. Last thing I want to show you before I show you about importing new libraries is this is a different data set. This is housing prices based on a whole bunch of different information about the particular house. So just another random data set I pulled. So what's the square footage of the first floor? Full bath, half bath. I'm not really sure why these are decimal points. I just threw this in here as an example. But what this is doing, oh, of course I know why these are decimal points. These aren't the actual values. What I'm showing here are the correlations, and there's this built-in CORR thing that you can run on a data frame of values that shows you how each of your input values correlates with other values. So we see that as lot area increases, the overall quality of the house, which is, I guess, some recordable metric, increases with some slight correlation. That's what this is telling us. And there's quite a lot of numbers here, but we can also visualize that, which is really cool. So this is the same thing, but now visualized. So this is a histogram because on the just the diagonal here, we'd be comparing overall condition to overall condition. So of course we would get a perfect correlation there. So instead what it shows us on this diagonal is a histogram of the values of all of our samples. And there's something like 1,500 samples here. So there's a lot of different houses that have data. But the overall condition of the house is it's a quantized thing. It's 0, 1, 2, 3, 4, something like that. There's a whole bunch that are kind of quality 6, and then just a few others. And we can see that when there's dots that are spread across rows like this versus dots that are more scattered, that's because we're dealing with some kind of quantized thing. So year built, for example, is quantized to a specific year. And overall condition is similarly quantized. So that's why we have these nice lines here. So there's a lot of cool things like that you can do. Here's a heat map that shows, again, the correlations between different variables. The darker, or I guess the lighter it is, the more there's a correlation. Yeah, the lighter it is, there's more correlation. I've kind of zoomed in so we could see that there seems to be a big correlation between the overall condition of the house and the year built. You might expect that. No, that means that there's less of a correlation. That's interesting. That's something to explore. More histograms. There's all kinds of cool things you can do in Python. I have to slow down or move, I guess, to the next part here because if I had more time, I could really delve into how you create all of these things. And I love to talk about that, and I'm happy to do it outside of this, this particular webinar. But back to the presentation, now that you've seen some things in Python, let me show you how you can install more Python libraries. Python was not created to be a tool for the oil and gas industry or a tool for geoscientists or petrophysicists or something like that. But there are libraries that are useful in Python to help people in various professions. And so the way that you want to import libraries that contain all kinds of cool functions that do things like what I was just showing you but more particular to the oil industry and more relevant to your workflows, is you go to your command prompt. And for some of you, you might have to open your Anaconda command prompt. So if I type command command, and I open this command prompt, my version of Anaconda, this will work for me. For others of you, you might have to instead search your computer for the Anaconda command prompt. And then what you do is you type this request, pip install requests. So pip install requests. And that tells my command prompt and Python that what I want to do is I want to give Python permission to look online for something that I tell it to download, find everything that it needs, and download it and install it into my Python in Anaconda form. So if you type this pip install requests, you've now given permission for Python and Anaconda to do that, to do what I just said. So the next step here is you can go online and find any sort of exciting library that you want. For example, here's a cool one that I thought might be relevant to you guys. So it's in the pypy.org. There's a whole bunch there, but they're all over the internet. This one is called the Well Log Spy. So what's the description here? It's a package to visualize oil and gas well logs in order to make interpretation and petrophysics analysis. That sounds pretty useful. This does not come with Python. A lot of those other packages that I was showing off in here and stuff, those things come with Python if you install it from Anaconda, versus these things don't. So if you want to install this, the next step would be you go to your command prompt again and you just type pip install well log spy, and that's it. It'll just work for you and install it. So let me try that. Pip install well, and then there's a third L for log. So well, then log, then SPY. And then if I hit enter, I think it's going to say it's already, yeah, requirement already satisfied because I already installed this. But now it's ready to go. And if I were to open up, you know, another, this is my example notebook from before, I could say import well log spy as, well, I don't even have to do it as something. And notice Python's thinking about that, and then it accepts it. So now well log spy is ready to go, and I could pull from the well log spy library by just asking Python. I just hit the tab key after putting a period there. What do I want to deal with? Maybe I want to deal with petrophysics. And then what else is there? Oh, cool, there's all these things. Pick something I know about. I'm running out of time here, so we won't really explore this one too much. But there's all kinds of things like this created by open source communities. And if you want to learn how they work, there's great documentation in the website typically, right? So my command prompt looked like this. It said requirement already satisfied. What yours might look like is more like this. Oh no, whoops, that's the one where I already had it satisfied. I should have taken a screenshot when I installed it the first time, so you'll see that it's something different. But if you try to install something you already have installed, it'll check for you, and then it won't, you know, add more stuff to your computer. It won't take up space if it's already there. It will update it for you though. So the only line that I typed was this pip install well log. Okay, so I'm coming to the end here. If you have more questions about the content today, if you rewatch this video or you're inspired and you start to play around with Python or something like that, and you want more example code or you want some lessons to sort of tinker with, just reach out to me. Like, this has been like an intro to sort of show you the context and what kinds of things are possible, and just barely scratching the surface about how to actually get going doing scripting yourself. It does take more time, and that's just because it's so powerful. There's so many things you can do that it's hard to kind of get you all up to speed in the course of just 1 hour. But that doesn't mean I'm not willing to help. So if you have any more questions, like informally, I'm not going to charge you or anything. Just like reach out to me through any of these methods here. More formally or more professionally, if you actually want to systematically learn Python quickly and practically, like for whatever your goal is in the workplace, so that you can either get things done faster, like automate something, or so that you can use data science methods to drive decisions, that's huge. I think that's like where the world is headed for sure. If you're the kind of person who, given a workflow, that, you know, has taken your predecessors and, you know, is expected in the job description to take you like 6 hours or so per week, because you're having to open lots of different files and browse down and find the right information and then put it in the right place and then double check that there's no typos before you can then start to analyze your data. You can automate all of that stuff. You can, you know, spend maybe 3 times as long the first time and then never spend any more time on it again because you've written a script to automate it, right? Or at least to drastically expedite it. And because you own that script, you understand how it works. So you then own the improvement in your company's efficiency, you know, and that's very valuable. Like, everyone will want that script from you, and then some people will want to learn it, some people will just want to use it. So it's a really good way to become indispensable, is to, you know, improve efficiency by automating something or by creating a step change in people's productivity. And then there's this whole data-driven decisions thing. Given what contemporary data science can do, what these machine learning methods can do, if you ever have to go present some kind of analysis to, you know, people who are running a company, and it's data informed, then you're kind of infallible, right? You can say, hey, here's all the data, here's the method I ran, let me explain how this method works, let me show you some examples and make it transparent to you. Here's what the data is showing is correlated, and here's what it predicts will happen if we do this versus if we do that. Now you guys can make the decision. It's not like you are trusting your gut and just saying, from my experience and my instinct, I'm going to stick my neck out and make this recommendation. Instead, it's very much like, hey, this is you know, the correct answer based on everything we've seen so far. And there could be more to the story than what we've seen, but let's explore and learn that, you know, and no one can blame you for that. And it's a great way to, you know, drive some influence in whatever work you're doing. If that's inspiring to you, then reach out to me, and it's really fun to kind of learn this stuff and get going, not just in Python, but, you know, because there's so much incumbent workflow in Excel, learning some Visual Basic, which is the scripting language for Microsoft Excel, is pretty useful there too. So I'm going to pause. It's 9 o'clock Central Time in the US, so we can now take questions. Thanks everybody for joining. What's my opinion about Julia language? Will it become the new Python? People are saying that. Oh, by the way, I'm just jumping right into answering questions. Annabella or Lori, stop me if there's something else that we need to talk about.
No, that's perfect. Go ahead.
Okay. All right, cool. So I've heard a lot about Julia myself. Honestly, I haven't played with it very much, aside from seeing somebody play with it in a conference. And it's one of those things where, like, there are so many languages. There's some slides I thought about including, but I didn't have time to show, that just show you what I call the long tail in developing languages, where there's so many different developer languages, and there's so many new ones every year. It's like the rate of acceleration and proliferation of these languages is just like so hard to keep up with. And typically, the people who use them love them and say, you know, that they're the best and will take over everything. And you know, for a long time, that's kind of how Python was. Like, just a few people used it and loved it, and then it started to grow quite a bit. I'm not sure if that's going to happen with Julia. I wish I knew how to predict that better. It's almost like predicting the stock market. If you know, like, that Julia is going to grow and be successful, and you get ahead in it, then, like, you're set, right? But that's certainly the case right now for Python, and I don't see the momentum slowing. So I recommend learning Python if you're interested in this stuff. How about Atom in comparison to Sublime? Yeah, Atom is cool. I think that, like, what's the other one? Text Wrangler and, like, Atom, these are not different scripting languages. These are environments that help you, you know, write your code. I think what people like about Atom, and I remember seeing this or hearing about this when I was in grad school, so a lot of computer scientists were saying, like, oh, it's very lightweight. Like, the amount of processing power it consumes on your computer is so small, even as compared to Sublime. And the reason they like that is that there's a lot of processing power left over to actually execute, you know, your code that isn't otherwise just sucked up from running the environment. And I'm you know, a little bit less of a sophisticated user than that. Like for me, if I err on the side of user friendliness, that's like better for me. Like I'd rather see what I'm doing a little bit more clearly than have something that's lighter weight to run. What does length mean? Oh yeah, so in the script that I was showing you guys earlier, len stands for length. And if you run len and then open and close a parenthesis, that's a function. So it's a built-in function in Python, one of hundreds or thousands of built-in functions. And it's a pretty useful one because it tells you if you have something like a list that has multiple items inside of it. Maybe you passed in a list from somewhere else and you don't know how many things are inside that list. How many items are in the list? If you just want to know that really quickly, you can just type len, open a parenthesis, put in whatever your list is, the variable, and then close a parenthesis. And when you hit Shift Enter, then Python and Jupyter Notebooks will tell you what the length is. Yes, a list of commands used in Python, and what does each mean? Yeah, Python, another good thing about Python is that it's very well documented. If you just search for Python documentation, let me just do this online right now. Search for Python documentation. Okay, I'm pulling this over here. So English, Python, that's in development, pre-release. All right, I'm going down to 3.8. Most of these things will be the same, 3.7, 3.8, they'll probably be pretty much the same. There'll be very small differences here. You can start browsing through this. If I wanted to search for len, here's length. It's a Python function. It's one of the built-in functions. Let's see what length does. Okay, it returns the length, the number of items of an object. So because this is from the Python developers, this has like everything in it. This is the definitive list. And it gives me examples, and it shows me like things that it tends to work with, and there's like a lot of kind of detailed stuff here. If I want something more practical, I can just search Google, and because Python is so popular, there's all kinds of information that's helpful online to help me learn how to use things. So maybe I want like most common Python built-in functions. Print, ABS is absolute value, round, kind of like an Excel will round a floating point to an integer or to a certain number of decimal places. What's the minimum value inside of something, et cetera. So there's a bunch of, yeah, these are all ones that I think I agree are pretty popular here. So there's great documentation online is the short answer. Can you share the Jupyter file that you showed? We can then check and apply what we saw. Sure, yeah, I'm happy to do that. And I have more structured ones, Vivek, that are like, here are the most common data types, and here are how they work and how you can interact with them. So I could share some of that stuff too. Best way to do that is to reach out to me here and ask me for them. And maybe there's a way through SEG to do that as well. So I can get with Lori and Annabella on that. All right. What's the difference between Python and other languages like MATLAB or Octave? I kind of talked about that. Biggest difference between Python and MATLAB, I would say, well, for some of that, there's a giant difference that you can draw a line down and categorize two different types of scripting languages. If it's open source versus if it's not. So Python is developed by a giant community of people who volunteer their time, and because it's such a huge community, and it's sourced from people who just want to help free of charge. For the most part, it's like pretty definitive and covers all kinds of stuff. Versus another type of scripting language is developed by a company, and that company has some sort of agenda. Typically it's to capture more market and make more money or something. And maybe it's ironic, but often those kinds of languages tend not to develop as quickly. When I say develop, I mean not like use a language to develop some script or write some code. I mean they're not as powerful. They don't have as many options as the open source ones. The downside is that the open source ones, well, they're open source, so if something goes wrong, you can't blame an individual and say, I want my money back, because it's free to begin with and it's just out there. I need to plot and view my well log curves like all these things side by side. Yeah, there are definitely ways to do that in Python, Anurag. So I don't have time to go into how to do that because there's a lot of dependencies. Like, how are you importing your data and what data type is it? And, how do you want to export your plots? And when you say side by side, you want to accomplish that in Python or inside of a, whatever you've exported file by file, then you put it into a PowerPoint presentation or something. There's a lot of different ways to kind of answer that, and it would take a while. But if you reach out to me, I'm happy to explore it with you. A way to analyze well log curves as we do visualize. Oh yeah, so that's kind of lucky because that well log spy thing that I happened to pull, Anurag, for your second question there from 8:57 a.m. I think that library I showed you could handle that. I've never used that library before, but there's all kinds of documentation for any library you find. In general, what I recommend is work with somebody professional. It doesn't have to be me to get up to speed on Python, so then you're kind of like dangerous on your own. And then once you're kind of past a beginner level threshold, it's so easy to like keep momentum up. If you don't have any scripting experience, it's kind of hard to just dive in, with that blinking cursor and like, what do I write? And I have some sense of what I want to accomplish. It's best to get some, take a class or, work with an individual who's done it for a while. But once you're there, then you can basically just search for whatever library you want online, and it probably exists. And once you find it, then you can get to work on learning how that works by yourself using the documentation. Can I show a library example for seismic data like I show the well log spy for well data? Sure, I can try. Let me see here. Seismic. Let me see. Python library for seismic data. Wow, Equinor, interesting. So, okay, so GitHub, I'm glad that I'm pursuing this question because I didn't talk about GitHub. Often people share their code on GitHub. This might be an example. So this dude, I guess Equinor allowed to share some of his stuff on GitHub. GitHub is basically like Dropbox or Google Drive or something, but for code. So the reason why a lot of people use GitHub is that it's collaborative. So if I upload code to GitHub and I'm actually working professionally with others, I can create various levels of like, privilege so people can log in and see various parts of my code, and then they can actually push code that is that complements my code towards a common goal. So it's kind of like a working environment for people in the software world. In oil and gas, we tend to be much more guarded with our data, unfortunately, as compared to in the computer science world. So I'm surprised to see this, but go Equinor. I think that's a step in the right direction. So I searched for, let me see, Python. Okay. I don't want to spend too much time on this, but there's probably some interesting stuff in this GitHub thing. So I wanted seismic data library. SegPy, this looks interesting. Transfer of seismic data. Aha, okay, it's a package available on Python index, great. So this SEGPY might be the one. Oh, here's Segyo. Oh, I see. So Segyo isn't a person. Segyo is another library, looks like. C library for Python and MATLAB. All right, so we have SegPy and we have Segyo. So there's at least two. There's probably a whole bunch. Oh, here's OBSPy. So you can kind of click through and maybe you find some example code online. And because something that's cool, that's like a positive feedback loop in this whole Python thing that's happening right now is, let's say that I want to get a great job and I'm on the market and I want to advertise that, hey, not only do I have some oil and gas experience, but I also know some Python. If I just put on my resume, hey, I know Python, most people who are in a position to check that, like HR people or general managers or whatever, they might not know Python. And, by and large, they don't in traditional industries like oil and gas. So how are they going to evaluate whether I really do? Do they just hire me and take me at my word? So what happens generally is people who have something to prove in the job search or, getting a promotion or, proving that they're the right person to do consulting work, they publish a lot of their code online and demonstrate it through GitHub and other, other ways to demonstrate code. And the reason that's a positive feedback loop is then you can click online if you're trying to learn how to do something and find all kinds of examples. And those examples might be hard to interpret if you haven't had any scripting experience yet. But once you get past a certain point, which is honestly not that hard to get to, maybe a couple of weeks of concerted effort, then you can, find and start to implement stuff. So if you wanted to make a decision whether you use Segio or SegPy or one of these other ones, the best way to do that is probably to look for examples of code that people have already written and see which ones overlap with your goals the best. Can Python script be incorporated in Excel? Kind of. It's not the same way as Visual Basic, David. It's not like you can just say, hey, oh shoot, I missed a couple questions. I'm going to answer David's question, then I'll scroll back up. Can Python script be incorporated in Excel? You can definitely write Python script that reads data from Excel, manipulates it, does all kinds of stuff with it, and then you can write Excel files using Python. And there are packages that do that. Pandas is probably the most popular one. Pandas, like the cute bear-like animals. So Pandas is a good one. And there's also I can't remember the name of it. It's called like Excel Py or something like that. You can search for it the same way we've been searching for other stuff. And you can do all kinds of stuff. Like you can specify the formatting, so that you're basically doing your entire workflow in Python. And then when you hit go, your output, which is what you share with people who need to see results in Excel, is completely in Excel. My own experience with that is typically when I look at the problem, I first make a decision, do I want to solve this problem in Visual Basic inside of Excel, or is it better suited for Python? If it's better suited for Python, most clients in traditional industries don't want the solution in Python. Even if I arrived at the solution in Python, they want it in Excel. So then I port it back into Excel when I'm done. And that's typically pretty easy to just write a quick file in Excel, and then I just do the formatting myself. But I'm sure there's fancier ways to do it. All right, I'm scrolling back to the top here because I missed a few questions. A list of commands, all right, I answered that one. Is there a way to import read MATLAB code into Python? There probably is. Generally, if you have a bunch of legacy code, like there's still tons of Fortran legacy code in a lot of traditional industry. Like when I was in downstream in oil and gas, we still had some Fortran, that people were running here and there. And if you just take that Fortran code and you try to use some fancy method to automatically convert it to Python or automatically convert it, those kinds of tools exist. And there are tools that claim to be able to do that for you. They tend to not work very well in my experience, but that's just my own experience, my own opinion. So I don't want to, give an objective sort of thumbs down to that concept. There are consulting organizations that will do that for you, and because they don't get paid unless you're satisfied, they have to do a good job. So that's a whole area. But what I really recommend is just get up to speed on the latest software. Whatever scripting language is the most powerful and most common currently, and then just rewrite your stuff. Even though that takes longer, then you get a refresher. You totally own it. You totally understand how it's working, and that just makes you more powerful in the company. Do you think you can provide us with data that we can play with? Sure. Actually, something great about if you're trying to mess with bigger data sets, scikit-learn, SCI like for science, SCI-kit-learn, scikit-learn. Is a really popular library, and I think that comes built in with Jupyter Notebooks. So you can import something from scikit-learn. You saw me do that with the support vector classifier as an example of a support vector machine for machine learning. And it has all kinds of built-in tools, but it also comes with some built-in data sets. Like that breast cancer data set is an example of a built-in data set. So you can just say, hey, I want to load the breast cancer data set from scikit-learn. Now you have this nice clean data set. Another one that I think it comes with is the really famous Titanic data set. It's a little morbid, but people love to mess with that just because there's so many cool insights that you can get from it relatively easily, and it's not very big. The Titanic data set is a true data set of everybody's class on the Titanic and where their port of embarkation, where they got on the boat. This is the Titanic, the ship that sank. How much they spent on their ticket, and then whether they lived or died, which is the morbid part. You can try to predict whether certain people of certain classes will live or die, or certain whether they're male or female or something like that. So that's another really common data set to kind of play with. Your kernel workspace, was that on your browser or was it Anaconda application? It was actually both. So something really clever about Anaconda is that when you open an Anaconda instance of Jupyter Notebooks, it uses your default web browser to host it. And the reason why it does that is that, especially if you're trying to work with Windows, well, I guess this is equally true of Apple computers as well. They push lots of updates to their operating system. And then it's like up to the provider, the software provider, to make sure that the software still works with that operating system. You're kind of like chained to Microsoft, and if Microsoft decides to change something arbitrarily, Microsoft can't consult every software company in the world to say, like, hey, is this going to be inconvenient for you? Microsoft just kind of makes decisions, and so does Apple. And then it's up to the software company to make sure that their program still works. So basically, Anaconda is piggybacking your web browser, because your web browser is doing all the work to make sure that it still works with the operating system. And so that way they can just have it work on the web browser. Also, it's kind of, there's all kinds of things you can do with Python online. We talked about like web design is one of the 4 big reasons why it's popular. So that's, it's kind of nice that you're already in a web browser. You kind of get used to the fact that things are sort of online. Python lends itself well to cloud computing and parallel processing on cloud computing platforms like Amazon's or Microsoft's or something like that. I would like to use how to use artificial neural networks, support vector machines using Python. Yeah, Gems, that's awesome. That stuff, like to teach artificial neural networks. I took a course from a Stanford professor on that, and I have about 300, and I think I was just looking at yesterday, 309 pages of notes just on artificial neural networks. That includes the convolutional neural networks and that sort of thing as well. So, it's kind of the definitive neural network thing, but that's a lot of notes, right? Like that's like a whole textbook. And those are just my notes from listening to lectures. It's a very deep topic. There's a lot of stuff to learn there. Same with, these other topics, support vector machines, depending on what kernel you use. And this is speaking about a different kernel than the Jupyter Notebooks kernel that was, counting the codes that I've executed. You can really spend a lot of time learning about how to transform your data so that you can draw nice lines or planes or whatever to fit for your support vector machine. That's a really big question. But I love teaching that stuff, and I do that professionally. So, maybe there's a way for me to help you, but you're in for, it's not like a 1-hour course. That would be, it might be a 1-hour course to learn how to use it, but that's a little irresponsible if you just use it without understanding how it works, because, that's when companies make big mistakes. And, there've been a lot of lawsuits, if you look up, maybe I shouldn't mention names, but like you have to watch out for trying to use machine learning methods that you don't understand. If you treat it like a black box, you can accidentally like skip over something and wind up with a model that will tell you to do something that you shouldn't do. So you have to watch out for that. Shuang says, very Thorough presentation. I missed the early part of the class. Do you have this recorded? Yes. Shuang, don't worry. It's recorded and it will be shared via SEG. I think even this part is still being recorded too. I'm on to Mohammed's question here. My question is how this software can be used in geology. That's a good question. You know, I showed that there are like some geology libraries out there, but I didn't really like explain like a use case, you know, like, oh, cool, we fit a model to some data, but so what? Like, why would we care? Let me give you a generalized, maybe a couple of generalized examples related to geology. Something that I've noticed recently is that exploration geology teams in larger independent oil and gas operators and in the super majors and in the national oil companies, those exploration geology teams are, you know, not across the board, but there's sort of a trend towards, rather than looking for, hey, where's unproven areas, as an exploration geologist, we can go explore and try to find whether there's you know, reserves to prove. And instead are looking more at proven reserves and distressed assets and trying to make a determination, is there enough value left in this field that we can buy it while it's cheap, while the oil industry is struggling. And in that, you know, towards that endeavor, they got to move quickly because, you know, what if the price comes back up, price of oil, you know, and then the asset gets more expensive? Or what if the company that, you know, the much smaller independent operator hit much harder by the current downturn, you know, say this is an onshore oil asset or something like that. What if they kind of get their feet under them and then say, never mind, it's not for sale? Or somebody else hurries up and snaps it up and buys it into their company. So there's a lot of need to quickly assess as geologists, what's the maturity of the source rock and how much of it has been consumed, which is maybe kind of in the RE territory a little bit. And so that gives rise to a lot of need for, you know, pull in data and analyze it quickly, develop some sort of method that takes into consideration all of the data and the correlations that emerge from that data, and then use that model, the resulting model, to drive the decision. And that can be done using Python. All right, so thank you for the introductory webinar. Sure, I have a few questions. One, I'm a novice when it comes to programming. No worries. Everyone starts from that same place. How can I approach, how to approach Python? I'll answer that question first. So I think the best way to approach Python is to work with somebody who already knows it. I think that like from 0 to 1 in Python is 0 to 1 in any kind of scripting, if you don't have experience at all with developing software, is like really hard and daunting. I wish that I had paid money, you know, to take a class or to work with professionals, you know, or a professional when I first got started, because you just flounder around on your own in the dark. It's like walking around in a room looking for a light switch with the lights off, and you're, you know, fumbling around every single wall and corner and stubbing your toe until you finally flip the switch. And then once you flip the switch, it's like, oh, okay, you know, now I can see my way around, right? Like if somebody just flips that switch for you, then you're just like good to go and you could cruise right through. So that's, I don't know if that's the best analogy, but I wish I hadn't spent so much time and effort fumbling around in the dark. To kind of make that a little bit clearer, imagine if you try to write a script and you hit go and you get an error. And the error says something like syntax error. You know, so as a beginner, you don't know that you're supposed to put a colon after your declaration of a new function. So you've written yourself a new function, and you saw some code online and you cut and pasted, and then you kind of worked the logic and it seemed to make sense. When you execute, you're getting the syntax error. You could spend like days debugging that when all you're missing is a colon. You know, that seems like a terrible use of time when someone could just tell you that and then, you know, teach you why there's a colon in a way that's intuitive, that you can remember. So if you really understand the basics, it's a great foundation, and then you can just build stuff on top of it. Learn some basic programs first or directly into Python. I'd say directly into Python and learn the basics of data structures and how things are referenced, and how, you know, pointers are how Python is actually storing data on your computer and that sort of thing. That'll make it much more intuitive. And then you can start building programs. then your second question, is there in-depth workshop for Python nearby? I probably shouldn't like advertise directly on SEG, but I offer that kind of stuff. I'm sure others do too. The way I try to focus is on like making sure that people understand how Python is working from like a very basic level, so that you have that like foundation that I just talked about. But then from there, it's like practical. It's like, all right, so now let's actually do some examples of workflows that might come up in the office, you know, maybe in the oil and gas context. Have any other videos that dive into some of these tools, or just videos in general to get going? It's a good idea, Tyler. I haven't, I don't think, recorded too much. Maybe you could search for me on YouTube, and there might be some stuff somewhat related, but I haven't published my lessons directly just on YouTube. It's so much fun for me to do it, and I like to tailor it to the audience. And so for those two reasons, I've been trying to make it a professional, you know, I'm trying to make it a profession. You know, I want to do this to support myself, so I haven't like shared everything so directly. But I'm definitely happy to share some stuff. So if you reach out to me directly, I don't have to take money from you in order to teach, just because I think it's fun, you know, to sort of point you in the right direction. I could share some things. So Natalie, working on PhD project with MATLAB, awesome. Do you think there's a good idea to start rewriting my code in Python, since it's an open source platform? Do you think this would be a better skill to acquire rather than MATLAB? This is kind of a straightforward question. I think if your main goal, like if you're really far into your project already, and your main goal is to showcase, you know, your dissertation, like what you figured out having used MATLAB, then, you know, maybe stick with MATLAB. It's okay. Once it's kind of like let's say that all of our mother tongue was Japanese. Everyone on this whole webinar spoke fluent Japanese and did not know any other languages. Learning MATLAB would be sort of like learning French or something. And once you know MATLAB, you know, then if you need to learn another Romance language like Python or JavaScript, or, you know, that would be like Spanish or English, you know, as compared to French, it's a lot more similar than as compared to Japanese. So that analogy is kind of like, as humans, we already know how to speak human languages, but when we're trying to learn computer languages, once we've learned one of them and we kind of get a sense of how coding works generally, and, you know, it's a lot easier to learn a second or third language. So I've found that I've been able to make quick progress in, you know, JavaScript and in Python, having started off with Visual Basic in Excel. But if your goal, Natalia, is instead to not only finish your dissertation, but also have a skill that is very marketable in demand in the workforce, I think Python is probably more marketable and probably in more demand than MATLAB. And that could be false in certain niches, you know, but just generally that's kind of the direction things are going. Yeah.
All right, then I really want to thank you for a wonderful webinar. For the attendees, we have a following webinar on building an end-to-end solution using machine learning. It's the first part. It's split into our next webinar is September 24. We needed you to have knowledge of Python to understand that webinar, so be in the lookout and register for that one as well. And I want to thank everyone for your time today. Thank you so much, Alec, for delivering this presentation. And thank you all. Have a nice day.
Thanks for having me. Yeah. Have a good day.